Hi everyone. Let us look at the LeetCode problem 916 word subsets. You are given two string arrays words 1 and words 2. A string B is a subset of string A if every letter in B occurs in a including multiplicity. So when we mean multiplicity, I think they have given a good example here. If you see, now take WRR. It is considered to be a subset of warrior because you can see, right, there is one instance of W and at least 2+ instances of RR in warrior. But it is not a subset of world because here world has only one instance of R. Even though the characters are there, there is not enough R's in world. So you cannot consider it to be a subset. A string A from word 1 is universal. There is words 1 and words 2. So words 1 is not considered to be universal if for every string B in words 2, B is a subset of A. So now in this example, if we take Amazon, E is not there in Amazon. So that means this cannot be universal, even if it satisfies the condition for O. But if you take Apple, same thing, sorry, Apple is also same thing. It is not a valid subset for valid subset for O. Now, but if you take Facebook, it has both E and O, so it is a universal superset. Okay, and so on. Now, let's try to see how to solve this problem. Let's start with a very brute force approach for this. One way we can think of is, if you take for example Amazon and I have its character set map, then what we can do is we can run this through all the character set maps for words in E. So this will be like, we will check for each of them. But if you see here, it doesn't match for any of them. So then it's not valid. But if you take the case of Apple, so E is there, then ape, it can also be formed from Apple, and ALE is also a subset of Apple. So if you see, Apple is valid, and if you see in this case, none of the other ones are valid. So your output will be Apple. But now if you see that whatever approach we mentioned, then that means we will have to run a algorithm of time complexity order of n into L1 into m into L2. The reason is assuming n is the number of strings in word 1 and L1 is the total length of word 1, and then m is the number of words in words 2 and L2 is its length, because you will have to run a loop within a loop. Now the question is there some better way to handle this? Now let's go into a different direction or a different intuition for this problem. Let's first try to identify what is the minimum character superset that we need for E, ape and ALE to become subsets. So if you see here, for this string I need 1E. For this string I need 1A, 1P, 1E, and for Al I need 1A, 1L, 1E. So that means I should have a superset string, and if I combine everything and take max instance of each of these characters, then I need at least 1E, 1A, 1P and 1L in my superset. I hope this is clear, because we are taking each string separately and try to make this a subset of another string, and for that a superset string should contain at least these character sets. So now what we can do is, then we can actually run through character set for each of these words in words 1 and see whether it satisfies the minimum character superset. Either it should match the minimum character superset or it should be greater than that minimum character supersets for these characters. And like that we can do it for each of these words in word 1. Now if you do that, then the overall time complexity to iterate through that will be order of n into L1. So if I figure this out first and then run through another loop to find this out, then our overall time complexity will be order of n into L1 plus order of m into L2. I hope the intuition is clear. Now let's do the code for this. The first thing is we need to find minimum superset for words 2, so that we can store in a character set. Now let's iterate through each word in our word 2. Now here what we'll do is first we'll identify the character set for each of the words. This will be for auto and ch. Here we will just keep accumulating that count. Okay. Then what we will do is we will now iterate through all the characters in both the array and store what is the maximum number of instances of a character for attaining the minimum superset. I hope this is clear. So either whatever is currently there, if that is greater, then we will take that one. If not, if this is greater for the current string, then we'll take that one. So this should be good enough for our minimum superset identification. Then what we'll do is we will find if any of the words in word 1 matches the min superset configuration. So superset character set. Now let's check each of the words. We will create the character set for each of the W1 words first. So this will give us the entire character set for W1 word. Then we will just check. We'll assume that there is a match. So this will be a constant time operation because its size is fixed as 26. Yeah. So this has to be either be greater than or equal to our min superset character set. So what we can do is if it is less, then we can straight away tell match is false and we can just break from the for loop. If match, then current element is part of the universal set. So then we can just return out. I have to also initialize out. So I hope the code is clear. So first we will identify the minimum superset for words in word 2. So this will be of the order of m into L2. So as you can see, we have to iterate through each and every string, and then this is a constant time operation. So the overall time will still remain as order of m into L2, and we will update the min superset character set that we need. Then what we'll do is we'll go through each and every word in W1 and see whether each of those W1s in word 1, whether it is able to match the minimum superset configuration. If not, we will make the match as false. If it is a match, then that means it's a universal word and we can push it to the output. So this time complexity will be order of n into L1. Okay, where n is the number of words in words 1 and the total length of words 1 is L1. So then the total time complexity will be the sum of these two. Our total time complexity will end up as order of n into L1 plus m into L2, and our space complexity will be, if you see, this will be order of 26. This will be also order of 26. Okay, here also this will be order of 26. So this can be considered as constant space. So this will become order of 26. So this is time, and order of 26 is equivalent to order of 1. So space will be this much. I hope this is clear. Have a good one. Thank you.